Hello, my name is Thomas. I'm the CTO and co-founder of Isovalent, and you are listening to the Disco Posse podcast.
Perfect. You nailed it.
Excellent.
And from there, we jump right in. So Thomas, thank you very much for joining today. This is really exciting for me personally on a lot of fronts, and for my audience on also equal amounts of fronts, because I've been watching you, your team, your company, and your approach for quite a while. And so by a beautiful, marriage of things that came together, I got a chance to be able to get you on. So thank you very much for joining. For folks that aren't familiar with you yet, if you want to just give yourself a full introduction, and then we're going to jump in. We'll talk about Isovalent, the Cilium project, and work outwards from there. There's really a ton of stuff we can cover that's going to be very interesting. Great.
First of all, thanks a lot for having me, Eric. I'm really excited to talk more about Cilium and Ebpf. My name is Thomas Graf. I'm based in Switzerland, so I grew up in Switzerland. I stayed in Switzerland because of the skiing, but I have been involved with mostly US companies in my professional career. So I've spent 10 years at Red Hat doing Linux kernel development. So that's my background. I have been a Linux kernel developer, very low level, focusing mostly on networking and security. So I've worked on IPv4, IPv6, traffic control, routing, TCP, and so on. Many different things, IP tables, firewalls, pretty much anything that is somehow related to Linux networking. Then after that, I spent a couple of years at Cisco during the OpenStack days, working on Open vSwitch together with the Open vSwitch team. So I've been a core member of the Open vSwitch team. And then while I have already been following Ebpf as a kernel technology, saw that this will change the world. So started the Cilium project with a couple of friends, and that eventually evolved into a full-blown company that we're now running.
And to talk about that one, your approach is always very interesting, and I have a big admiration for your really strong focus on using open technologies, open communities, very positive impact stuff that you're doing at the code level and at the community level, and then wrapping a commercial organization around it, which ultimately has an even greater give back, that it creates commercial opportunities for people, brings jobs. It's a really interesting balance of being an open tech company and being a viable startup and growing an organization. So, when did that kind of come into your mindset that this is where you wanted to really push your focus into staying strong on open technologies?
Yeah, I think this is the biggest shift over the last couple of years that happened to my personal life. Is in the beginning, I was immediately sold on open source. I was a full-blown evangelist around open source back in the days when it was still Linux versus Windows, and it was very clear that from a software development perspective, from a moral perspective, open source is the way to go regarding software development. And I've always been using open source software. I've always spent my career developing open source software and so on. And then there was some point in my career where I wanted the next level challenge as well. And I saw creating a company, creating something that has more impact than just usage as the next potential challenge. And it got me really interested. At the same time, I did not want to disabandon my open source background. Like, it was very clear from the beginning that whatever I would do, it has to be built on the foundation of open source. It was not difficult to convince myself, because I was coming from Red Hat, and I saw Red Hat grow from tiny into a multi-billion-dollar company. So to me, I didn't actually challenge myself too much that open source would not be a viable business model. It has been, I've seen it working, and I've seen it be successful. And at the time when we started, there were already several other companies that have been insanely successful around open source. It doesn't mean that open source and business success come together automatically. It's obviously still a big challenge, and it's a major part of my daily work life right now to make the two ends meet well together and make sure that we're both successful from an open source perspective, which we definitely are, and also successful from a business perspective, which we're definitely are as well.
Well, and to talk about a business perspective as well, I should give congratulations here for a recent announcement of news. So you've received funding through Andreessen Horowitz, Martin Casado, who led that round, and so that was fantastic news. I've got such a massive respect for Martin and all that he's done, and of course you've got Dan Wendlandt on the team as well. You've really got such a great team, and Neil Jacques, who is your runs the marketing side of things. So I'm a longtime fan of Neil. He and I have rode a bike together a couple of times here, and he left me in the dust in many places, which was fantastic. He's so really your people that you've brought have a great history in open technologies, and so it's really exciting to watch that come together. And, I definitely wish you lots of future success as well, even beyond what you've already achieved so far. So, but let's talk about the eBPF, the sort of the light that you saw that you realized was going to be the bright light that needed to be captured and used. How did this technology and how did this as a protocol become important to you in seeing a problem that needed to be solved?
I think, I think the perfect question. It's exactly what matters. And there's two angles to it. So I've been involved in developing infrastructure software for, I think, over 15 years at this point. Like initially during the physical server age, during the virtualization age, and I've always been on the Linux kernel side. And I've usually been in a position where I was involved in a team to develop the building blocks, which would later be used to develop the actual infrastructure layer, whether that's sort of networking technology, firewall technology, visibility technology. And a fundamental limitation has always been that, it's very difficult to modify the Linux kernel. You need software engineers with a lot of experience. You need to convince the entire Linux kernel community that your change, whatever you want to do, is right for the entire Linux kernel community. So everybody from the server field to the embedded field, you need to convince everybody. And then it makes it even more difficult because once you have the changes in, it will take years and years and years for that technology to actually make it into the hands of the users. So what happened, I think there was a moment where this became very obvious to me during the early days of OpenShift, right? That's OpenShift. I noticed what are the building blocks that OpenShift is using to implement what it wanted to implement. And it was features I had written 8 or 10 years ago. And it made it so obvious that this is not a model that we can continue, because at the point when you're building these building blocks in the Linux kernel, you have no idea what the future use cases will be. At the time we wrote those building blocks, there were no containers. Namespaces just came up, right? There was very, very early days, IBM and others invested into namespaces, but there was no notion of a container. So whatever building blocks we built back then were built for a different use case, and this always led to abuse of the building blocks. And when I saw eBPF, to me this changed everything, because I immediately saw, and I was obviously not the only one, obviously the other people involved in eBPF saw that same value. I saw this can have the same impact as something like JavaScript had for browsers. All of a sudden, you don't need to ship new versions of the browser every time that you want to extend a bit of functionality. You can program your browser with JavaScript. And eBPF is exactly the same to the Linux kernel. Obviously, it's a lot faster than JavaScript, but from an impact perspective, it's very similar. It's the programmability and the safety aspect, which make it incredibly powerful. And it fundamentally changes how the building blocks or how the Linux kernel development can be done. You can dynamically load the code. You don't need to merge source code into the Linux kernel. You can run bytecode. You can run logic in the Linux kernel. You don't have to wait for a new kernel version to make it into the hands of a user. An existing Linux kernel version with an eBPF runtime can take on any program. So this changes everything. And instead of instead of using building blocks that have been written 8 years ago, you can write your own building blocks right now for the use cases that matter right now. And this has changed everything.
There's an interesting balance that you just sort of highlighted, that there are a lot of core technologies that have a beautiful effect years later, because they have to sort of be vetted out. We look at stuff like, especially overlay protocols became one of the real sort of battlegrounds for which would be the one that would hold the standard going forward. And people, of course, forget that when you have like they use an RFC as like a marker. Well, it's request for comments. It's actually not a finalized standard. It's just the most broadly used of other RFCs. And we saw that with everything in the networking, such as BGP, and people will still war over whether that's the right choice or not. Mm-hmm. And then you get into eBPF, same thing, where really the foundations have been laid, and now we can exploit those foundations for, in a positive way. I say exploit sounds like a naughty term because it's, seems negative, but it is very much like leverage and use that capability for today's use cases. Now, yes, when you're developing that low layer, because you've got such a broad history of being at the foundation, at the core, how do you design something at that time and think of use cases that, like, how do you introduce a use case into your product management sort of mind, trying to think further ahead, because it won't actually be touched for potentially years?
It's an excellent question. It's actually, I was not aware that product management existed for a very, very, very long time, because in the world of kernel development, there's not really such a thing, because the delay is so long that whatever customer impact or whatever customer needs are around, it's not really what you should be thinking about as a kernel developer in the traditional model, because whatever you're building, it needs to be applicable for many, many, many years to come. And that's usually not really what like the core of product management often is, right? Product management is often a lot more short-term focused, driving product needs for immediate or based on immediate customer needs. So I was actually not aware of how traditional product management works in a software company, because it's simply a concept that does not exist. But now, if we have eBPF, you can think about the eBPF runtime development, which still happens in the kernel. That is still with this long-term vision, with this broad horizon. But then as you leverage eBPF, and as you leverage projects built on top of eBPF, you can now get into a mental model where you can actually address customer needs right away. And I will make a kind of an example here. We saw a steady and sharp increase in user space networking in Linux just after the virtualization age has happened. And a big part of that was because Linux networking has been focusing entirely on the server use case forever. Like the typical Google use case, I'm running thousands and thousands and thousands of servers. On that servers, I'm running applications. They need a TCP/IP stack to talk to the outside world. That's it. That's what Linux has been optimized for. And all of a sudden, Linux was in a position that, hey, I need to manage VMs. Hey, I need virtual functions. Hey, I want to build middle boxes with Linux to implement firewalling and so on. And Linux was not built for this at all. And this is why we've seen a shift towards user space networking, because that gives you exactly the same flexibility as something like eBPF. It gives you the programmability. You can bake in whatever you need right now. So with eBPF, we have regained that same capability, and we can provide the same functionality, the same flexibility as user space networking can.
And I think this is the important thing too, when you look at the risk that we introduce as we get closer to the kernel. And that's why the right abstraction towards giving programmability, user space access without having to go below, because that became one of the biggest sort of linchpins for people to have a run at Docker and containers in general, for fear that it's too close to the kernel. It's too close to the underlying system, which would then potentially expose root level access and introduce security risks. And this is the interesting thing with networking, virtual networking. It started to quote Martin's, original paper when he brought Nicira to the market, was that he was bringing a security platform. Networking was the path by which you would achieve this security, but ultimately it's much more security than just routing. Routing is important, of course, and then we see this when we look at the Cilium project, And the stuff that's going to go on in the Kubernetes networking, it's vastly more complex than any networking that we've in the industry had to be exposed to before. Mm-hmm. And so maybe talk about your choice to start Cilium and what was the original goal to that, and what did you, how far ahead did you see, as a commercial opportunity when you actually started that project?
Yes, I think it's actually, it's almost a perfect context, because I think Martin actually plays a role in this. So as I mentioned, I was involved in Open vSwitch, which was the open source project of Nicira. It was the building block, right? And there are many parallels between Open vSwitch and what we're doing with Cilium, but there are also a couple of differences. What we saw while working on SDN or network virtualization is that first of all, it brought a ton of programmability and flexibility into what type of networking can we actually build. So instead of waiting years for new hardware versions or for new iterations of particular hardware to come around, you could now write code and it would be available almost immediately. It didn't really change anything in terms of what type of like terminology or building blocks or concepts were used. Instead of a physical router, it was now a virtual router. Instead of a physical switch, it was now a virtual switch. Programmability was around flow tables, which is incredibly similar to what you would do in hardware. It's some data structure that you can program. We were not using arbitrary programs back then, right? It was, here is my programmable flow table. If you see this flow, then do this. If you see this flow, then do this. So very, very similar to hardware, which I think was absolutely the right incremental step from hardware-based networking into software-defined networking. The reason why we started Cilium is because, and I think Martin shares this vision as well, we saw that Martin's vision was only like step one. And there is a natural next step, in particular if containers and Kubernetes comes into play. If you have the full power of a general purpose CPU available to you, why don't you use it? Like, why restrict yourself to building blocks that are networking specific? Ebpf is kind of, if you compare what OVS enabled network-specific programmability, what Ebpf enables general purpose or all close to general purpose programmability. So it's actually not networking specific at all. We can do system call filtering, we can do visibility, tracing. There's Linux security modules written, Ebpf seccomp is written, or there's an Ebpf seccomp implementation. It's more than networking, which allows to look at, like you could call it an SDN 2.0 or whatever, it's just a cloud native networking, whatever we want to call it. The next age of networking can benefit from a generic programmability. And I think the biggest shift overall on a high level from virtualized networking or SDN and what we now see in cloud native networking is that we are removing the assumption that networking is fundamentally about devices or machines, but it is about applications. So instead of arguing, okay, I have some sort of machine, whether that's a VM or a container, and that machine has an IP and we somehow need to connect them, we're now arguing about services, applications, and understanding them and connecting them together. It's a vastly different way of thinking about how to do networking. And the reason why that is required is primarily we're running at massively larger scale. So it's even during OpenStack days, there were still kind of the pets versus cattle term, right?
Yeah.
This is a lot more extreme now. Like there's absolutely no chance to do any pet naming anymore. And even if you manage your cattle, it has to be a whole different scale perspective, like a whole different scale. And we can dive into the details how Ebpf helps there, but that on a high level, that's the biggest shift. That's why we started Cilium, to really get to a cloud native network level that deeply understands applications and is not fundamentally machine based or device based.
And it's an interesting thing because I think we've in a way we've kind of rocketed past IPv6 in its functional solve, right? Like it was meant to solve the problem of addressability, but it was very raw device level addressability. So we cheated, we got NAT to survive the death of, the address range for IPv4. IPv6 broadly used, of course, in telco and lots of organizations, but the true like application, the L4 to L7, this is where the real, as Martine would say, the Goldilocks zone is. We talked about, the right place to address the problem, because I think the industry and the development field has arrived there now. But if we look back at OpenStack days, we weren't ready. Like, the applications were still being refactored. Using the application layer as a way to address and access wasn't known to be the popular way yet. And I think in a weird way, even like I'd say Kubernetes effectively is thriving on the back of OpenStack, because we learned a lot of hard lessons with what OpenStack was trying to achieve, and the world wasn't ready. So I appreciate that. So you talked about, let's actually dive in. What does eBPF do for us now that solve this fundamental problem that's deeper than just raw networking?
Yes, so I think before eBPF existed, the only choice you would have to dynamically extend the behavior of your Linux kernel was to load a Linux kernel module. And that concept was invented to load device drivers. So if you buy a new piece of hardware, you will need to load the driver codes to support that. And this matters a lot less these days, because typically you're running in cloud, or often you're running in cloud, and the matrix of supported hardware is just much smaller these days. But that's the concept that still exists. The major downside of that is, first of all, a Linux kernel module is typically bound to a particular kernel version, because it will access internal APIs, and these APIs are not stable. So as a author of a Linux kernel module, will have to modify your code and make it depend or make it function for every new kernel version. But even more severe, it has major security implications. Any bug in a Linux kernel compromises your node. Yeah, your entire system is compromised, because the Linux kernel module has exactly the same privileges as native Linux kernel code. eBPF is different. eBPF gives you the same ability of dynamically extending and loading code at runtime to bring in new logic, but it's doing so in a safe and efficient manner. So let's talk about safety first. eBPF is, at the core, is an x86-alike bytecode, which is generic. So it's not specific to what your CPU is running. It's generic. So you can have a eBPF bytecode that implements some logic, and you can load that into any Linux kernel, no matter what CPU architecture is powering that kernel. As the kernel receives this bytecode, you will tell the Linux kernel, I want to run this particular piece of code on some event. For example, every time a Linux network device is receiving a packet, or every time a packet is being transmitted, or every time a particular system call is being invoked. That's how system call filtering is being done. Or every time a trace point is being hit, or every time my particular function in my user space application is being invoked. That's how application tracing is being done, and so on. So you tell this to the kernel, and then the first thing the kernel will do is validate whether this program is safe to run. So eBPF is not a carte blanche. You have to comply with the safety rules of eBPF. So the program cannot access arbitrary Linux kernel functions. It can only access a well-defined API, which is stable, which is a subset. And you're not directly calling into other kernel functions. You're calling into so-called helpers, which then allow you to interact with the Linux kernel in a secure manner. You cannot loop forever in a eBPF program. So there is support for so-called bounded loops, but it has to be guaranteed that your program always runs to completion. You cannot expose arbitrary kernel memory, and so on. There's a long list of security requirements that need to pass. Even the program complexity is capped. So you cannot run a program that takes 2 minutes to complete. It will completely stall your kernel. Your program cannot sleep right now, and so on. So once it passes those safety rules, and only if it passes those safety rules, is the program loaded. So from that perspective, it's very similar to a container. It's sandboxed. It doesn't have arbitrary access. It will run in a well-defined, secure, isolated sandbox. And then to talk about the efficiency, as I mentioned, eBPF is actually generic, but the Linux kernel will just in time compile it. So it will take the generic bytecode and translate that, for example, into x86, 64, or whatever CPU you're currently running. So in the end, you end up with a natively compiled or JIT compiled piece of code that is secure to run, that you can run in a long list of well-defined hook points in the kernel to extend the logic there.
Well, it's one thing that actually is very important, especially now. You mentioned, of course, x86 64, which we effectively see as the sort of most broadly used standard at CPU architectures, but I think that's about to rapidly change, right? We're
exactly,
seeing,
yeah.
Of course, we've got the M1 chip on the Apple side. We've got ARM is becoming a much more popular, especially on the cloud side. We've got AWS with their own underlying architectures, Intel, of course, AMD. Everybody is coming to the fore now with viable alternatives. And so this flexibility and adaptability and programmability is incredibly important, because we're going to see it in Kubernetes, especially when we go to the edge. There will not be Intel architectures at the edge for the most part. It's just not going to happen. And it's always funny, as like, I'll say, as nerds, we love the idea. When we say ARM, everybody thinks Raspberry Pi. You're like, no. There's there are many devices. Raspberry Pi is a good place to do a little sandbox test of it. But
it's actually more. It even unlocks offload and into SmartNICs, for example, right? If you have this generic piece of bytecode and a well-defined API of helpers, that means it all of a sudden becomes offloadable into, for example, SmartNICs, which is already possible.
Right.
And that is because the bytecode is generic. It's not bound to anything specific on the hardware side. So that ties again into something like OpenFlow. It's generic enough so you can offload it, but it's a lot more general purpose. So it's still not networking specific. And I think eBPF has struck an ideal balance and an ideal compromise between general purpose bytecode or general purpose instruction set, but still a well-defined API that you can still offload it to SmartNICs, because like there is a network program type which is very networking specific, and it's very obvious that from a SmartNIC perspective, you only want to offload those network. You're not going to offload system call filtering to a SmartNIC, right?
Right.
I think that's very powerful. So the JIT is not just for x86 versus ARM. It will actually also go down into, let's say, SmartNIC offload, which again can bring a new security angle into play, because all of a sudden you may no longer depend on your main CPU becoming or being kind of the privileged piece that is executing the code. It could actually be the SmartNICs, which could be in an entirely different trust domain from a security perspective.
Yeah, it's interesting you bring that up now, because SmartNICs are not new to the industry, but they're renewed in the industry. In the same way that sort of we've talked about GPU as a potential to do parallel processing for a long time, but it really did take quite a while before it became evolved as a broadly adopted and used standard, because maybe it was like the systems, the OSs, the applications didn't line up with being able to use it. And SmartNIC, I'm seeing this, sort of come back to the fore again. Whereas we probably talked about SmartNIC offloads and TCP offloading for a long time. That was back to like even Novell, was trying to tackle that. This is the funny thing too about our industry, is that everything old is new again. We talked about like loadable kernel modules. And I remember back in the days of being a Novell administrator and running live NLM loads, and you could just dynamically load and unload modules as needed. And Windows created this sort of like very locked in monolithic architecture for operating. And now, here we are again, where all of these things are coming together, because I think we're all ready for it in a better way. Now on the side of taking this and then developing a community around it, what's your approach when you create Cilium and want to really get it out there? Because I'm curious, people talk about open source, and just putting it on GitHub does not make it open source. Open source is much more around the way in which you engage with the potential other builders, developers, consumers of that product or platform.
Yeah, it's exactly what we believe as well. So when we started Cilium, there was no moment that we developed this for a year internally and then open sourced it. Like there was no open sourcing moment. I've always find it weird if a company open sourcing something is being seen as something very positive, because I think it's still better than not open sourcing it, but it's not really the ideal model, because a lot of the early on design assumptions will have been baked in, and it was not open when those happened. What we did with Cilium, I think we invested maybe a couple of weeks, maybe 2 or 3 weeks, and then we pushed it out to GitHub, and we had a first appearance, I think, at the at Linux Foundation Open Source Summit, I think it was called back then. And we talked about, hey, Cilium, this is going to be the next gen container networking. These are our design assumptions. We made very extreme assumptions, IPv6 only. We're doing load balancing, both east-west and north-south, everything eBPF based. The firewall completely different, not IP tables based, but security identity based, like a lot of fundamentally different assumptions. And we went out there and told the world, this is how we see networking being done in the future for containers. Obviously, not all of the concepts we have embedded into Cilium are made from us. A lot of them have been derived, for example, with Google and Facebook and other big do-it-yourself cloud providers or big infrastructure companies are doing, and how they're running containers successfully for many, many years. And we've taken some of those concepts, made them a bit more general purpose, brought in more concepts that may be a bit more specific to back then initially Docker, now Kubernetes. And that was the assumption. That's how we got out there and said, this is what we're building. If you're interested, join us. And immediately people started joining and were interested. And a continuous stream or a continuous cycle of feedback and new versions came along. So Cilium was really out there and open from the very, very beginning, which is, I think, what led to the great open source market fit as well. That Cilium is really addressing what matters now, because we have been working with the relevant people that have been running containers for a long time already, and they knew the problems, and we could learn from them. And you can only do this if you're open from the very beginning. If you're coming out there with a complete solution and you open source it once it's complete, still nice, but you won't get kind of the full benefit of the open source of the open source community.
Now, it brings up an interesting challenge in open communities and open sourcing a platform or product, is that at some point there's potential where somebody will want to introduce something into the core that, as a maintainer, you may not necessarily agree with. And I'm always curious, how do you deal with sort of conflict, having done, so Linux development, of course, one of the most famous hardlined product managers, of course, Linus Torvalds, effectively the final say on many things that enter into the core, into the kernel. We look at where there were challenges with Docker, where Solomon Hykes had taken a very strong approach, and eventually there was a moment where he and the team, effectively the maintainers, had to decide, no, this will not go into the core. It needs to be solved elsewhere. Where have you bumped into that? And how would you deal with a potential conflict in what belongs in the core of Cilium, perhaps?
I think every open source maintainer of any successful open source project will deal with problems like this. And I wouldn't call them problems actually, but like with challenges like this. Right. It's actually a fun fact. One of the main motivations for eBPF to be merged into the Linux kernel was actually several arguments between very, very, very big Linux kernel users, which were all trying to add additional metrics, additional networking metrics into the Linux kernel for visibility they needed. And there was a huge argument that, okay, you need this metric, but I don't need it. Why should I pay the cost for you to maintain this metric? Right. And eBPF was seen as a solution for this dynamic programmability. If you need this visibility, if you need this control, load it in at runtime. We're only giving you the sandbox to do so safely. And we are using that same concept in Cilium as well. Obviously, there are limits. If you are trying to fundamentally change what Cilium does and it has implications, then you will definitely need a a majority of the existing Cilium committers. But in general, I think, and that is probably true for any open source project, as long as you can manage consequences of change as well. And consequences can be performance related, can be maintainability related, and so on. It's all about managing those consequences. And typically, solutions can be found that the consequences are not paid by others or third parties. So if you intend to change something, you should also be the one to pay the consequences for any fallout or for any side effects. That's usually a viable, good strategy on how to tackle this in general, and can allow the community to thrive without kind of risking to destroy it. Because I think, and I don't want to use Docker as a bad example in particular, but I think many successful open source projects, and Docker is an insanely successful open source project, many of those projects have all suffered at some point from I'm successful, this means I know what is best.
Right.
And I think that is dangerous at some point. You should never forget, or an open source maintainer should never forget, that you're not right all the time. You should give others a chance to prove that they're right as well. And sometimes that cannot be done in an email. Sometimes that cannot be done in a GitHub comment or something like that. You need to give them the opportunity to merge code, to expose it to users, and then derive the right conclusions from that. So it's all about providing a safe environment that this can happen without compromising the overall open source project. But again, of course, this is easier said than done. But that's our strategy overall.
Yeah, and it's always, I feel terrible sometimes when I bring up the Solomon example, and I can't even remember what the specific was, where I think it might have been the OCI standard being merged, and they said, like, this goes counter to what we believe is, what belongs in the core. And we all survived it, but it was a very strong moment of clarity as to, it had grown to a point where this difficult question had to be dealt with. And as you said, this is not a problem so much as a challenge that it will at some point at scale, need to be dealt with. And Kubernetes is effectively goes through that. Even the turning over of things to the foundation, where like turning over governance, this is an interesting challenge where we saw Istio going through this battle where, Google and a lot of the maintainers said, no, we're good. We're going to keep a hold of this for a little longer. And almost in what you talked about, the like building for a year and then having your open source moment, to a lot of folks, it feels like that turning over for governance to the CNCF or to any foundation is that, it's already open, but there's a maturity or there is a marked difference in the way that project will operate now when that happens. So what are your thoughts on, that sort of right time to open it up or to turn over the governance and control of a particular project?
I think I can understand the legal side of foundations and donating IP and all of that. And there will be a moment where we will do that for Cilium as well. But if I look at the importance, and that's my very personal opinion, if I look at the importance between governance practice and the legal foundation side, I would say the legal foundation side, maybe 20% of the importance. And probably lawyers will probably disagree with me at this point, but I think what's way more important to me is that the governance model that is lived, who can influence what, is way more important in general. So the code is open source, it's available. If the practice and the rules put in place on who can do what are functioning for the entire ecosystem, then it matters much less who the IP belongs to, because let's be honest, depending on where you live in the world, the rules are actually, the law is very different as well. It's a very complex topic. So I would say what we made sure from a Cilium perspective is that we are completely transparent in who gets commit access. How does that process look like? How much do you have to get involved in the project to get commit access? What is decided by committers? What is not decided by committers? And then on top of that, living a culture where, no, there is not a single maintainer ruling everything. there are certain moments where I would say you as a maintainer, you want to jump in and shortcut something, but if there is this fundamental disagreement, there's no maintainer just overruling. That's probably where we are primarily different from a Linux kernel-based model. It's also where, for example, Kubernetes is very different. Kubernetes also has the same very community-style development, very consensus-driven model, a very standardized Kubernetes enhancement proposal process. I as an individual, and it doesn't matter whether I as an individual working for a large vendor or doing that on my own time can come in and propose something, get consensus, and then do this. As long as this is very clear, I think that actually matters more than the pure foundation side of things.
Yeah, and I think that's the, having again sort of lived through the challenges in the way that OpenStack had been, what belonged in core, what belonged under, what fit under the big tent, and we saw a lot of difficult learning lessons in how to manage a massive community with massive numbers of projects that had the potential. And it's funny, you brought up the example of like introducing metrics into the kernel. And I remember doing this through my team. We were trying to expose additional metrics for CPU and memory utilization inside Nova and Ceilometer. And the first thing that would happen is that they would say, wait a second, I see your email address and I know what your company does. Mm-hmm. This looks very self-serving. And so we actually had to go out of our way to do additional important commits to the core code that were not related to a commercial exploit, because it was always seen as like, if the first thing you do now creates commercial viability for you, people are a little suspect of your motives to put it in there, which is also this weird balance of, I'm a huge proponent for open source, and I'm a huge proponent for being able to build successful companies thriving on open source technologies. So I'm maybe I'm a little bit more of an open source libertarian on that side. That I do believe that both sides are incredibly important, because the commercial side supports continuing to maintain and grow those communities in the same way. So, I
think that the most important aspect here is that there must be a contract between everybody who is interested from a financial perspective around an open source project and the open source community. Those two are not, there can be a lot of overlap, but they're not the same. So how does that contract typically look like? If the open source community is not sure whether work that is being done by the community is then exploited by somebody else, then people will typically get out, right? Like, why should I enable somebody? And it doesn't even have to be one vendor versus another vendor. It can also be just somebody spending their own personal time.
Right.
Or even if people are working for a vendor, it's not necessary that the vendor comes in, but mainly kind of I'm investing my motivation, my energy. I don't want to feel abused. So there must be a contract. What is like, like, everybody understands that in order for an open source project to be successful, the companies backing that open source project, whether that's the startup behind it, whether that's the company employing the people working on it, then there needs to be a balance, and that balance needs to be defined in a contract. That can be a foundation model, but typically takes more. It should be, or it's best to actually write this down to make it clear for everybody, so people get into the project, they know, like, how does the commercial situation look like, and then you cannot really change that fundamentally. So you cannot just all of a sudden, like, close something and so on. That is key, and that ensures. And I think OpenStack was very early on in the world where there was not a lot of experience with that. If we look at the Linux kernel before, most commercial entities coming in, they were seen as something hostile, right? Like, nobody was supposed to make money off the Linux kernel. And OpenStack was a very large, successful project that did not really have any experience beyond that, or the open source community did not have experience beyond that. We're in a fundamentally different place now, and you can see it was possible to see this evolve from like Linux kernel, OpenStack, Docker, Kubernetes, and so on.
And I guess it's a perfect, link to the move now to create Isovalent. And how did, I'm always curious, where is the inception point where you say, I see what we've got. We've got a fantastic, technology that we can build in the open, and it will solve a use case or a number of use cases. And we see the business value now. And then that decision to say, I believe we can wrap a commercial, entity and create success in that side of it as well.
Yeah, I think the main reason why it was clear that we want to build a company around it relatively early on is because we wanted to make sure that the open source project has a lot of broad impact, right? Like it's bringing some change. The change we wanted, the change we saw, and we still believe in as being the right model. That's probably the main reason for a lot of software engineers creating open source projects in the first place. But that means you need people on the project. These people, everybody wants to receive a salary, so you need a company behind it, right?
Yeah.
That was the kind of the driver for, okay, let's have a company. And overall, it was, I think, clear, and this is not something groundbreaking new, but if you are the networking layer of large infrastructure, you're at the center of everything. Like, you're incredibly important and absolutely critical. There is no point, I think, in assuming that somebody's not willing to pay you money for the guarantee that this very crucial layer is working. Right. Like, simply, or for the same reason that like the Linux distribution or the cloud provider, like all of those well-defined critical layers, there will always be money flowing into it. So it simplifies the problem down to, okay, how should the product look like? Is it like a support-only agreement? Is it a support plus open core model and so on? Those I think are all nuances. And yes, it matters in the end, but it's actually a bit less important from a high level perspective. What's important is we wanted to build the next generation networking layer for the upcoming cloud native world. And if we are successful with that, there is definitely room for a company. That was our base assumption, and that's definitely been rendered valid. So we didn't struggle at all to find ways to productize it without conflicting with the core belief around open source, without violating that contract that I just talked about. Like, this is open source. We're not gonna violate the trust that the open source community is putting into us. It was actually not challenging to come up with that at all, I would say.
Now, when did you, this is very much built on first principles thinking versus, what we generally see in most of, a lot of companies, a lot of projects that are in open source, especially they're incremental improvements on there, but you're taking on a fundamentally different approach with a strong viability, but there's now this path that has to be mapped out in order to gain adoption, see this to success at scale. Where does that background come for you in being able to take on such a challenge and think in that real solid first principles methodology?
So this is where the team comes in, and it's interesting because it kind of depends on each other. So as a business person, what is incredibly appealing is if you succeed with bringing on an entire new shift of something and building a new platform, and I would call SDN is something like this. Like, it's a major industry shift. Kubernetes containers and what we're doing, we're seeing that as another insanely big shift. In every time such a shift happens, it means that, you mentioned this before, like, it's the same problems that come up over and over and over again. We're not solving fundamental different problems, but we're changing how we solve them. And changing how we solve them leads to different products, which means you have an opportunity to as a new vendor to come in. So as we succeed with a big shift overall industry, we also get the chance to retool everything to provide new tooling around visibility, firewall, networking, load balancing, and so on. And that's exactly what we're seeing right now. We're seeing all the traditional networking layers, all the solutions that are out there being rewritten in eBPF. And obviously, as a company, we want to have the biggest possible part of that. In order to achieve this, you need the best possible team, right? So there's not a single person out there who knows or understands how to do all of this. So from the very beginning, we made sure that we made a key focus to make sure that we have by far the best team. And from our perspective, we've definitely achieved that. And it's probably what we're most proud of as well. We have the team to drive this. It's not me or Dan or some one person individual being able to drive that vision. It's the overall team with a lot of experience, having built this for the last 15 years in different ages. Applying that to this new world allows us to bring this new shift. Obviously, coupled with fantastic investors, Martin, Google, Cisco. There's
Right.
a lot of experience, a lot of knowledge and experience coming in, allowing us to do this.
Yeah, and it's funny when we think in the entrepreneurs and startup world, they talk about they call it the 3 T's: team, TAM, and technology, right? And then and it goes in that important order, in that you have to have belief that the team can execute on a vision. They can have this vision, they share it, and then they can execute as a team and build an organization, especially as you grow a company too, because it's a fundamentally different thing than just solving a problem at a very deep technical layer. Then, of course, there's the total addressable market, which is important. You know, you
Yes.
talked about sort of the scale at which this is being implemented. I walk into customers every day. They're doing these like large scale Kubernetes environments, and it's amazing to watch, even where we would call it fully productionized implementations, but they're very early days in so much of the way they operate that infrastructure. And especially when it comes to networking and security, it's effectively an open field.
Yes.
And so they are simply taking the best available path at the moment, and it's more finger crossing that it won't go sideways than it is in true belief that they've already solved the problem. And then, of course, the technology is, like you talked about, like with the power of eBPF, the power that's being done in the core unlocks those 3 beautiful things of the right people, the right need, at an industry scale, and then put all those 3 together.
Mm-hmm. Exactly. Yeah, it's exactly how we see this as well. And the number of what we would call traditional enterprises coming into Kubernetes last year has been mind-blowing. I think we've seen this with any sort of open source wave. It always looks a bit brighter than it is in the very beginning. Like everybody tries to claim I'm running in production, where maybe it is true, maybe it is not true. Nobody really knows, but it always takes a couple of years longer than everybody wants to. Last year has been absolutely amazing. Like the profile has fundamentally changed, and the profile of customers and users coming into Kubernetes is easy to classify just based on the needs they have. Whether it's like cloud only, everything greenfield, or here is my long list of existing enterprise needs. I need all of the same.
That's right.
But with container awareness, right? And all of a sudden, instead of having one product, you're trying to figure out, okay, we can build 5 new products. Which should we build first?
Yeah.
And that's exactly where the overall market is right now.
It's amazing to see the like I said, the variations in the field at scale. And I remembered even, like I said, Kubernetes, I still bump into this question a lot of times. Somebody will say, like, I'm not sure that it's going to be able to, scale. They're like, I'm fairly sure that it will scale, but what's your sense of scale? And you ask the person quite often, they're like, well, we've got like, 2,000, 3,000 workloads. I'm like, you're fine. You're fine.
Mm-hmm.
You can probably run it on VirtualBox. You're good. Don't worry about that, but the OpenStack faced the same battle of like at scale that became this detractor of like, I don't know how it's going to work at scale. Like, well, we haven't discovered scale yet. And we're getting there. And thus we saw federation had to happen because it was a profound problem once we saw the adoption grow. And, RBAC became the way of dealing, because obviously it's first is scalability, then there's identity. And then you now are coming in with the problem that we've had all the way through that we've just been denying, which was security and networking is going to be the biggest exposure for risk in building and operating, not just design. I can get it to work once, but how does it work on day 2 and beyond in an adaptive, application-focused world? The old model will not grow, and that's while it may work it may work today, it's brittle. And I've seen it, where people are really starting to fight the struggle. So yes, when Cilium opened up, a lot of eyes widened and a lot of people smiled, saying, "I think we have something amazing here." So I'm excited by what's ahead for it.
Yeah, I think you actually brought up a very interesting point. Like, what is scale? Okay, most people think about number of machines or size of infrastructure about scalability first, and I think that was probably quite accurate during virtualization. I think the biggest shift or the biggest change from virtualization to where we are right now is that scale is no longer just infrastructure size, but it's also multiple teams deploying several times a day, massive complexity around the CI/CD pipeline. Everything is automated, a mix of multi-tenant clusters and teams deploying in parallel, ideally completely separated from a security perspective, but then still using, for example, Kafka clusters, which are shared. Okay, coming from a world where everything is assumed to be isolated, right? The teams are kind of assume I have my namespaces, everything is kind of isolated away, and then all of a sudden they share resources again, and so on. When we talk about scalability, it's mostly around that. And then if you bring in edge clusters or multi-cloud, or even just bridging legacy workloads running in, let's say, a bare metal data center, or even, let's say, EC2 VM fleets or something, how do I connect this to my new style Kubernetes workloads? That's another form of scale, because all of a sudden you're required to provide security for, let's say, virtual machines, and you can no longer assume to have all of the new style building blocks, but you still need to scale. So you now kind of need to solve scalability problems on traditional workloads as well, which is something we're working on or have just released a couple of weeks ago. If we talk scale, it's not just the size of infrastructure. It's really the combination of overall infrastructure, team complexity, policy complexity, CI/CD complexity, churn, how many times do you deploy, and so on.
Yeah, it became the sort of what OVS had to build, the challenge of like the scale was not in the number of devices and the endpoints necessarily. It was the size of the TCAM table and what it had to store and distribute. And that became the thing. It wasn't just the importance of the size of that table and but the ability to distribute it in using consensus, understanding the foundations of Raft and like the things that we now in the development methodologies are coming together. We've got Kafka that's being broadly used. We're seeing much more, the message bus used to be for, MQ, back in the days of mainframe integrations. And that became the biggest area where people were thinking that way. And now we're seeing the application scale is growing. But you brought up a really great point. It's not going to be all there. It's not going to be all greenfield. We are going to see a hybrid in a sense that is traditional, we'll call it legacy virtualized workloads and cloud native and just even cloud IaaS and cloud platform as a service. They all have core needs, which is where, like I said, you and the team have got something where everybody's going to need you. And by adapting a new technology, adding support for any other virtualization, hypervisor or whatever, it immediately opens up this world in a beautiful way where now those companies that want to use this, they don't have to get rid of one thing to adopt another. Because I think that's the biggest risk we run into as an industry is this unfortunate belief that you will build data center B, migrate data center A, and we will refactor it while doing that. And just, it didn't work. So where will the importance of legacy workloads come into play when we talk about Cilium and Isovalent's story?
I think it's a lot less important from a pure Cilium perspective.
Right.
Because open source projects, we're always kind of the beacon out there, like pointing the way. This is how it should be, and like concepts and vision all around. This is the ideal world, right? Okay, everything is security identity based. There is no IP based filtering anywhere, and so on. That's the ideal. That's a perfect world. If we go into what solutions Isovalent and what problems Isovalent solves, it's often a enterprise that might not move quite as quickly as it wants to have Kubernetes, and has been assuming, oh, I actually need to migrate, and the migration and the move has been slow because there's complications. It's actually not quite as straightforward to take an application that is running in a VM and just containerize that. There are side effects. Like one side is just building the container image. That's easy. There are side effects. Like being able to assist in that and say, okay, take your new workloads, take the new applications that you're writing. We allow you to embed your existing workloads and represent them in your new Kubernetes world, just as they would be just as if they would be running as a container, and kind of eyes open up. Oh, amazing! Right, so I don't have to block my project on my unsuccessful migration. I can start green, represent the workloads in my new environment. I can build the security modeling and the security audit, all of that in the new world, while still respecting the old legacy world as well. It's a bit more on the commercial and enterprise side, not because it's actually all open source, but mainly from an interest perspective. It's a lot more enterprise use case driven and a lot less about open source visionary mindset. There's a lot of very exciting technology in that as well. I think it's just if we talk at, let's say, open source conferences, there's a bit less excitement around that legacy.
That's right.
That legacy workload path.
Yeah, I always laugh when people talk about legacy, and I said my line is that you call it legacy, I call it production. Like this is I worked in environments when I started at an insurance company in the tech side, and I was on the distributed team when it was early days of distributed. This was like early NT, Windows NT days, and we were literally called like this team that was on a fad of like building these the business is in the mainframe, the data's in the mainframe. We've got more ETL people than we have distributed systems people. So it doesn't make sense that you have these distributed IT ops people, that are putting these servers all over the place. Well, next thing you know, we had 2,500 servers and complex applications and multiple environments. And I was like, oh, okay, this is not a fad. This is actually going to go, but it didn't upend the mid-tier, the mainframe, the mid-frame, like all of those things will continue to exist. It wasn't really a war over the hill. It was a war over a place on the hill, and the importance of that. And that's why, like you said, every enterprise organization has big eyes with we are going to refactor everything. We're going to move to completely cloud native. And then they realize you couldn't even, if you just shut the doors down, if you could stop the world, it would still take 2 years to do it, but you're not stopping the world because business goes on, especially in the course of the last year. So you chose to launch a company not even when you didn't know that there was potentially a risk, but like you were very much in the throes of a worldwide pandemic, and the world of business is different. How did what influences then came in when you're trying to build your plan and think about where you were going to implement? I'm curious if it obviously came into play, but like how much does that now influence the way you think about the first year and 2 years of growth?
The decision when to launch was entirely done based on market traction. As soon as we saw that, and that's why I mentioned last year, we saw just a very steep increase in like traditional enterprise use cases coming up. And we saw all of a sudden we were asked to do, okay, these are the next 5 products that we should be building. What is the most important one? Or like, what will be the most successful one? That was the clear signal. That's now the market is ready to launch. Maybe the signal would have been even stronger if COVID did not happen, but it was even with COVID, it was very, very strong. I could obviously make an argument that overall IT spend is going up, like there's more budget being spent on automation. How specifically that actually affects us, whether it's positive or negative, we probably don't even know. There are probably a couple of customers that deprioritized, they were deeply impacted, and there were others that were actually insanely enabled, let's say retailers with online shops, for example.
Right.
So I'm not sure how that, like below the line, what that actually is. COVID's impact overall, I think our immediate main concern was just employees. Let's make sure that everybody in the team comes through this pandemic with a sane mind, and that is still the top priority. So the business side, well, obviously always incredibly important. As it comes to COVID, I think the making sure that we get everybody in the team through this has been almost exclusive focus. And the company thriving and the company being successful is obviously a part of it, but it's not the only part.
Yeah, and that's again a sort of a testament to the team you've chosen and built that you wrap around it, which is that has to be at its core. Where your first priority. It's always difficult because when we talk about like positive things that have come as a result of what we've exposed ourselves to as a society, right? And I never want to say positive, but I think of it as like positive lessons and where we have opportunities to create new things. We have not felt the full brunt of the effect of, on the world of COVID and the commercial aspects, especially when you get like large enterprise deals. People often say like, oh, we had a tough quarter. But that's when we'll feel the effect. Like, no, you're going to feel the effect in 3 quarters because the prospecting you're not doing now won't be known until, those deals don't close for 9 to 12 to potentially even longer months. So now this is the interesting thing too. And you're a distributed team. How does the time zone, like how do you work together? How do you collaborate as a group?
So first of all, it's been something that's been familiar to myself. I've always worked in remote teams. I've always managed remote teams as well. So that was natural. Some of the principles that I'm aware of, which I think work in general, is you cannot have a mix. So you cannot have some in office, some remote. If you have remote, then all the information needs to be accessible. The discussion needs to be accessible to everybody. That was not really a struggle. I think we're clearly, even we had pre-COVID, we had about half the overall company was working in an office, but even there, dual headquarters. We have an HQ in Mountain View and one in Zurich, Switzerland. Even that was distributed. I think the challenge that any open source team faces as it grows, and it's actually not specific to a startup or a company, but overall to open source projects, is you need to allow people to work in their own time zone. And you need to make sure that even if people choose to work certain hours, they need to be able to get involved, have a say in a safe way without requiring them to be on constantly. So like, there needs to be some standardization around where discussions are happening, when it is safe to sign off, like not just having a impromptu discussion around something and come to a conclusion and that's it. And whoever was online and everybody else didn't have a say. Those are the important parts. It's not really COVID specific. I think it for teams who have been entirely physical and then remote, that's a bigger challenge because they're not used to this. We have been used to this even before that as well. So we are, I think, quite typical for a startup of our size and an open source project. So we're using Slack, we're using GitHub, we're using like SaaS-based document editors and so on. That's our style, and obviously that's been hugely helpful in kind of not having to adjust too much as we went through the changes and got people to work from home more.
Yeah, this is the one, again, sort of a positive of the negative that we've experienced as a world is that it hopefully will open the doors to teaching people what collaboration is, not meetings. And people often say to me like, oh, you've got a lot of meetings, you must enjoy it because you like people. I said, no, I like collaboration, not meetings. And meetings are often not collaborative. They're just simply PowerPoint reviews and they're not really, and like I said, they're point in time. There's an assumption that there's a thing that leads up to it and then stuff that comes out of it. And it's very much dependent on who is physically in that room. And when you're the I've been a remote worker for a decade, from different companies. And it was first allowed and sort of enabled because I'd built the team internally and I'd had this experience, and then I had to move across the country and I was suddenly in a different time zone where there was a smaller IT team. And it was like, okay, I would never have been hired in the remote location, but I was allowed to move. And then from that point on, it was like, oh, this actually works great. As long as we collaborate, communicate, and like you said, respect the time zones and the offline hours, because that's the biggest risk, I think, especially in a startup, is that offline hours are something that are it's like the attention economy. Attention is the one thing that people are seeking, and a little bit of offline time is especially necessary.
Yeah, I think some of it you want a good mix, right? I think the thrill of a startup is a little bit of like burning fire. Let's like all hands on that. Let's fix it. I think some of it is actually exciting, but it has to be sustainable. Like it cannot be the standard model. You cannot operate in that model day to day. Like that doesn't work. I think overall, I think the main struggle we have been going through with COVID is to make sure that the people who working remote was not the norm before, to make sure that they don't feel completely isolated. Because like before the split was very clear, people who enjoy to be a bit isolated, work on their own, they would typically work from home primarily, right? And the people who don't like that model, they would primarily work from an office, and that worked great. That was like kind of a model that would like naturally work for everybody. Now, if you force one of the two models onto everybody, all of a sudden, you have to take care of the people where that model is not natural. So that has been one of the major focus, and with like team activities and making sure that people still feel kind of part of the company, part of the team. That has been helpful, but it's obviously very difficult to replace physical encounters.
Yeah, in an interesting way, when it comes to the event ecosystem, and it's funny, I remembered, the first time walking by, I forget which location it was at KubeCon, and I saw Dan and it was there, and with the small Stellium booth, and I remembered it was like, hey, all right, some familiar friends and faces, and I thought this is exciting, and I remember those days, but the advantage, I think, as an industry that we have now is that the event is not about the best t-shirt, the best swag, the best party, because unfortunately it creates a challenge for new organizations. Like, you come to an event, you want to showcase something, you're important to the ecosystem, but then you've got a massive incumbent vendor, and good on them, right? Like I respect them all, and I work tightly with all of them. But when a Dell, a VMware, a Cisco, comes in and they have a $2.4 million marketing budget for KubeCon, and you and I go there and we have a $2.4 million marketing budget for like we want to be effective in the community, and you're effectively competing for attention with somebody who's got jugglers in their booth and has amazing t-shirts. Like, I like in a way that we've democratized access to the community through online events. It's not easy though, for sure. And I definitely miss, there is a real collegial part of being in person, going to evening events, having, like, when we do SIGs and you do, working groups, it's very different when you can all grab a coffee, go to a boardroom, sit down together. There is a genuine difference in like how we collaborate in those short, packed periods of time. But we'll find it again in some balanced way. But for the interim, it's certainly going to be this way for a while.
Yeah, I think like everybody is kind of just longing to get back to conferences. Not for seeing vendors, but just meeting everybody. So conferences, we never, and that's probably also why COVID is not really impacting us that much. We never did that much prospecting at conferences. To us, KubeCon was around meeting everybody. Like we were basically at the booth, and people would stop by, you'd have a chat. Obviously, some people would still kind of come in or tell me about Cilium, but I think after the third or second KubeCon, most people knew about Cilium. So you were not pitching them about Cilium. It's like, hey, you will have a chat, or how's it going? What are you doing? And that was about it. And you would maybe have dinner afterwards. And so that's what we miss. The convincing the industry and the world of Cilium is not happening at conferences. Maybe the conference talks will help to some extent, but conference talks, they can be replaced. We don't need a physical gathering just for the talks, right? You could even replace that with blog posts or some other form of content. The convincing, and there's actually a very important point, the open source model has won before the big vendors did come in, which means just because the big vendors now came in and throw a lot of marketing dollars at open source, it doesn't change that. The open source model is still the same. Like the way successful open source projects are chosen is not just because of marketing dollars. Yes, you can change it a bit, right? If you talk publicly about it. But I would say even for very, very successful projects like Kubernetes, it's not the Google marketing dollars. No, it's because of Google, right? Google is clearly known as being able to operate at a really large scale. And the assumption that all of that experience went into Kubernetes, that's why Kubernetes has this standing, not because of the Google marketing dollars.
Right.
And I think that's why doing an open source startup is still really, really compelling, extremely compelling, because you're not really only competing on the marketing side and so on. You can win with superior open source technology, which is maybe why we get the number one question: how did you manage to get Cilium where it is without any marketing efforts? Until Neela joined us last year, we had no marketing whatsoever, like literally nothing. And it still allowed us to get known, to actually get a very, very good position overall. And the conferences were kind of a minor role in that. I think what we really miss is the meeting friends aspect.
Yeah, and it's definitely in the same way that I know in my own marketing team, we do customer meetings continuously at every stage of the cycle of, whether it's, pre-sales, post-sales. And it's because that is my open community, even in a proprietary, startup. I have to listen to who's interested and really genuinely have a listening role in what they're doing. What are the other things they're solving, even outside of what we're doing, because it helps me to understand, what are other challenges that need to be solved, and it can go beyond. And like I said, that to me was when you go to those events, like you said, the talks can be replaced. What can't be is that, hey, so this funny thing happened to us the other day in production. Like that stuff no one blogs about that, or because it is very impromptu. It's good. And it's funny. I remember, so when I talked with Neela quite a bit, and he mentioned, I have this very interesting looking company. And as soon as he said the name, I was like, go. I go. You're going to a great place with a great team. And Thomas, thank you. This has been fantastic. I'm definitely looking forward to all of the good things that are coming next. 2021 is going to be a build year for the world, for the team, and for the industry. But we'll catch up again as we get further into the year, because I'd love to get caught up as you continue to grow and see what's new as adoption increases, and where you see the industry too, because that, again, in the listening sense, I'd love to hear your stories on implementations and where we are seeing new challenges that maybe have not yet been discovered because we haven't hit that scale yet.
Mm-hmm. Thanks a lot, Eric. This has been a really exciting conversation. And maybe to close out, for those that want to learn more about Cilium and eBPF, I think there's one good place to get started: Cilium.io or ebpf.io. Open source resources with guides, tutorials, talks, references, and so on. So if you want to dig deeper, that's a good way to get started.
Yeah, and I'll make sure I have links in the show notes as well for folks to get in, because this is the beauty part about these things, is you can read the papers behind the technology, and effectively you can sort of see how the story played out with the team far before we saw it real. It's amazing to watch how I'm always amazed by, like, we talk about the joke of the 10-year overnight success of any company. And it happens in the same way with technologies, that this has been vetted out, maybe on a university campus for a long time. And like, that was when we saw OVS and how the inception of OVS was far before, it was a product attached to it. It was, it had to be thought about intellectually for a long time. And then, is this viable? Is this necessary? and then we see it come into play, and same thing. So Cilium is an exciting project. And like I said, I've got a team member, when I said, hey, they said, I'm looking at the Cilium thing, it's fantastic. I'm like, let me know, I can hook you up with the team, because we definitely want to get involved. So again, Thomas, thank you very much. And yeah, for folks, definitely check out cilium.io. Keep your eyes on Isovalent. I see big things coming, and for good reasons. You're a good team. You're a great person, and you're solving problems which are something that we are all going to be a little bit closer to than maybe we realized a couple of years ago.
Awesome. Thanks a lot. Thanks a lot, Eric.